And so today we have an FHWA presentation where we're going to talk about what is ultra-high performance concrete, look at some examples of how it's used, and then look at the everyday counts deployment plan for ultra-high performance concrete. And then Barry's going to come and talk to you about the Delaware Department of Transportation's experience with ultra-high performance concrete. And so getting back to the point I was trying to make there is we would like to get through our presentations fairly quickly so we have plenty of time at the end to answer any questions you have. And I'm Marc Leonard, and I'm with Federal Highways. Work for ANWR. I'm on the structures team with the Resource Center out of Denver. And prior to working for FHWA, I worked for the Colorado Department of Transportation for about 28 years in their bridge office. So what we're going to talk about today is we're going to start off and explain what is ultra-high performance concrete, what are the benefits to using it, and look at some examples of using ultra-high performance concrete for connecting prefabricated bridge elements together. And then we're going to look at the deployment plan, the everyday counts deployment plan, the purpose, goals, take a look at the state of the practice of using ultra-high performance concrete in the country, some challenges to using it, and a few details of the everyday counts implementation plan. So getting right into it, what is ultra-high performance concrete? Ultra-high performance concrete is a steel fiber reinforced concrete that has mechanical properties that far exceed that of conventional concrete. And it has a pore structure that makes it resistant to penetration by water and chlorides. The most important thing to know about ultra-high performance concrete, it doesn't have any special or magic ingredient you haven't heard of. It's Portland cement concrete. We're familiar with the ingredients. It's cement, aggregate, and water. However, it's a special or unique or new formulation of these ingredients. It uses a especially high amount of cement, doesn't have any large aggregate, and uses very little water, just enough water to complete the hydration process. It's castable. You can mix it and place it in a fabrication yard or out at the bridge site. And to help with the placement, it's usually self-consolidating. As you can see in the photo on the left here of a flow test, it flows like pancake batter. And without the large aggregate, you can see here that it looks a lot like grout. In addition to Portland cement, fine aggregate, and water, ultra-high performance concrete also has a large amount of steel fibers. So we use reinforcing steel in conventional concrete to carry tension, control cracks, and the steel fibers are used to do this in ultra-high performance concrete. I said there's a lot of steel fibers. I'll say it again. There's a lot of steel fibers. It's 2% by volume. It's about 250 pounds of fiber per cubic yard. Seen a bridge deck before they cast the concrete? And you see all that rebar in the bridge deck, and you say, man, what are those structural engineers doing with all that rebar? Well, oftentimes in a bridge deck, my experience is you have about 200 to 300 pounds of steel per cubic yard of concrete in a bridge deck. So what is the point I'm making? Is that kind of gives you a picture of how much steel fibers we're talking about in ultra-high performance concrete. About the same amount as you would have of reinforcing steel in a bridge deck. Superplasticizers are used to decrease the amount of water that is needed for the mix while still having a highly flowable mix. In addition to the Portland cement, there are supplemental cementitious materials, usually fly ash, and very commonly used silica fume. There's no large aggregate. The aggregate is composed of fine sand and ground quartz, which are formulated to work with the cement using particle packing concepts to produce a very dense, impermeable mix. And so what we'll pass around now is this is our dry mix without the steel fibers. So here you have your cement, your sand, and your quartz. Let me say that a different way. Here you have your Portland cement and all your aggregate right here. No fibers in this one. But did we get the hockey puck going? There are still fibers in that hockey puck, which is, as you can see, the steel fibers in that one jar, and then look at them when they're in the concrete that's been cast. It's not like, how should I say that? It's not like it's especially hairy, that they're all sticking out or anything like that. Okay, where was I? So compared to conventional concrete, ultra-high performance concrete is characterized by having a very high compressive strength, a high tensile strength, low permeability, which makes it highly resistant to freeze-thaw damage, and it's self-consolidating. Let's look at this high compressive and high tensile strength. Here we have a stress-strain diagram that compares the behavior of ultra-high performance concrete under compression to conventional concrete. Ultra-high performance concrete is defined as having a compression strength, a peak compression strength of over 21 KSI. In this example, the ultra-high performance concrete has a peak compressive strength of about 24 KSI, and the conventional concrete is shown as having a maximum compressive strength of 6 KSI. So the ultra-high performance concrete is about twice as stiff. As we see here, the strain response to stress, it's twice as stiff as the conventional concrete, and it's about 3 to 4 times stronger than conventional concrete. And even though this strength is very important, it's not as important as the tensile characteristics of the ultra-high performance concrete, which we'll look at next. This stress-strain diagram compares the tensile response of ultra-high performance concrete to that of conventional concrete. Ultra-high performance concrete is defined as having a peak tensile strength of 720 psi. In this example, the ultra-high performance concrete has a peak pre-cracked tensile strength of 1,300 psi. And the conventional concrete is showing as having a peak tensile strength of 400 psi. So the ultra-high performance concrete is about 3 times stronger in tension than ultra-high performance concrete. But more importantly, the behavior is fundamentally different. With the ultra-high performance concrete, after the first crack, the concrete loses all its tensile strength. With the ultra-high performance concrete, after the first crack forms here, the tensile strength drops slightly, but then it goes up again as the fibers extend across that crack. And then the next crack forms, and the strength goes up again. And we get this sawtooth behavior is the tensile stresses are transferred from the concrete to the steel fibers. And these fine, well-distributed cracks are shown on this photo on the right by these red lines. And eventually, keep pulling on it, one large crack forms and the member fails in ultimate tension. So tension is usually controls our design of concrete. And this difference in behavior lets us design things differently with ultra-high performance concrete. Prefabricated bridge elements can be used to accelerate on-site construction time and improve the durability and quality of our bridges. However, some of the benefits of using precast bridge elements can be lost when you go out in the field and connect them together with field cast concrete. And using conventional concrete, those connections between our prefabricated bridge elements, especially the rebar details, can be difficult to design and difficult to construct. Ultra-high performance concrete can be used to simplify the design of these connections. Ultra-high performance concrete is stronger, and it does a better job at transferring our stresses from one precast element to the other. Less concrete and less rebar is needed for the connection. But in addition to simplifying the connection, ultra-high performance concrete is more durable. So with ultra-high performance concrete, you don't have high quality precast concrete elements interrupted by connections with inferior concrete. The weak link in the system with prefabricated bridge elements is the connections. So here, we compare a connection made with conventional concrete and a connection made with ultra-high performance concrete. These connections are in a precast deck panel, full depth bridge deck panel. Conventional concrete needs more rebar and more concrete for the connection than ultra-high performance concrete. And not only is there less concrete and less rebar with the ultra-high performance concrete, very importantly, there's less congestion. Also with the ultra-high performance concrete, using the guidelines that are available, you don't need to have contact lap splices. So with fewer rebar, fewer pieces of rebar that don't need to be in a contact lap splice, we can get less interference in our connections. And looking at this picture, when we're thinking about costs, we see that we want to look at total cost of our connections instead of just comparing the cost per cubic yard. The cost per cubic yard of ultra-high performance concrete, which is very high, but it doesn't give you the full story or the full comparison to conventional concrete. There's more costs going on between these two than just the concrete itself that's being used for the connection. Let's look at some applications. You can use ultra-high performance concrete for the deck panel connections, for modular superstructure connections, substructure connections, and you can use it for overlays. Where overlays aren't connections. It doesn't belong on this slide, but I put it there anyways. Iowa, first project this year in the United States, they use ultra-high performance concrete for an overlay. I'm thinking Delaware has got a project in mind where they would like to use it for an overlay. So even though it's not a connection, I have it here to illustrate that given the durability characteristics of ultra-high performance concrete, there's other benefits to using it beyond connections. Let's get back to connections. That's the subject. This is a diagram that illustrates the project in I-81, Syracuse, New York, of using precast deck panels for a bridge deck. And you have your interior panels, precast panels, you have your median panels with the bridge rail already attached on this project, and you have your exterior panels with the bridge rail already attached. And on this project, the approach slabs were also precast. This is the same project, photo of them placing the interior panels. And not only is the ultra-high performance concrete used to connect the panels together, but you can use it to connect the bridge deck to the girders. And here we have the shear studs sticking up off the girders, and ultra-high performance concrete will be used in that haunch area to connect the panels to the girder. Same bridge. This is all the panels in place before the ultra-high performance concrete has been placed. You see your combination of longitudinal and transverse joints. We have our interior panels, exterior panels, and here we have the approach slab panels. And then looking at the bridge deck after it was completed, the light gray areas show you where the ultra-high performance concrete connections where they're at. Now, given the durability of the concrete in these precast deck panels and the durability of the ultra-high performance concrete and the connections, you don't necessarily need to use a protective wearing surface on this bridge deck if you don't want to. And in this particular case, New York didn't. And what they did is they milled the entire bridge deck to provide a very smooth, durable bridge deck. Let's move on from bridge deck panels to modular superstructure sections. Side-by-side orthogonal box girders are very popular in many states, but there's been problems with longitudinal cracking at the joint between the box girders. And typically, designers use a combination of details, more complicated than what you see here, to provide to help prevent the cracking, or at least mitigate the cracking. So what do I mean by a combination of details? Sometimes they'll use transverse post-tensioning. They'll use much deeper shear keys. I've seen some details where they'll put a world of rebar at that joint. Well, with ultra-high performance concrete, there's the opportunity to simplify the connection and have a smaller connection with simple rebar details with a very durable concrete along that connection. another modular superstructure type. Some states, they like to use the bulb T-girders without a deck, and in this case, the traffic rides right on top of the top flange. Well, it's important to have a strong concrete for this connection, and also a concrete that is durable enough to withstand the exposure to the weather and to vehicle traffic. Ultra-high performance concrete, state of Washington is looking at it as a solution for this connection here. I believe the state of New York, one of their earliest jobs, if not their first job, they use ultra-high performance concrete in this application. And by this application, I mean with the deck bulb T-girders. Project in Iowa. The modular superstructure units were a pair of steel I-girders, or I should say the steel I-girders came to the field in pairs with the bridge deck already attached. And an ultra-high performance concrete was used to connect the modular superstructure units together. On this particular project, this is the Keg Creek Bridge. The entire bridge was precast, so consequently, ultra-high performance concrete was used to connect the substructure to the superstructure. So yes, substructure elements can be precast, can be fabricated ahead of time and brought out to the field and connected together at the bridge site. And those connections can be made with ultra-high performance concrete. This is a project in New York, an abutment. And the abutment was connected together using ultra-high performance concrete and was connected to the superstructure using ultra-high performance concrete. And as with we saw with the bridge deck panels, we see that we have narrow connections, smaller connections, small quantities, simple rebar details. Little interference going on in these connections. Little rebar interference. Our last example, we'll look at splicing some larger bars. We'll also go back to New York. On this particular project, New York was connecting a new pier cap to an existing column. Number 9 bars, they are able to use lap splices and with ultra-high performance complete the connection within 1 foot. And for any of you that design lap splices, you know, well, even with number 5s, you're starting to get into a couple feet as far as a lap splice. But if you have a Class D lap splice with number 9 bars, you would need several feet for that connection, especially if they're epoxy coated. It gets even longer. Well, again, New York was able to do it with 1 foot. And one of the things that's so significant here is with a conventional concrete connection, they would have had to remove several feet of concrete from that existing column. But here they only needed to remove the 1 foot. Made it a lot more practical. Another example, the cost is more than cubic yard. There's more going on there. Potentially more going on depending on your application. All right, so what did we just do? We took a look at what is ultra-high performance concrete, what are some of the benefits of using it, looked at some applications. So let's just real quick look at some of the elements at the Everyday Counts implementation plan for ultra-high performance concrete and look at the state of the practice in the country. One thing I felt to say at the beginning of the presentation, at any point, please interrupt me if you have any questions. And if I say something that doesn't make any sense, it's good to catch me right there and let me correct that. So ask questions at any time. I don't know that I've had any experience with the wear rate on precast concrete decks. In Colorado, because of the connections, we were typically using membrane and asphalt on them. But I'm wondering if the wear rate on precast deck panels is that severe. Because with those, we're using like 10 KSI concrete in those panels. I'm sorry, go ahead.
It's just interesting because in the Northwest where you do have studded tires, it's surprising how much that Portland cement concrete does actually run.
But saying it again, I'm thinking oftentimes that pavement, and boy, I've seen that rutting. It's 4,000, 4,500, 4.4 or 4.5 KSI concrete. And with your precast concrete, you're typically getting, or we were at least, getting concrete around 10 KSI for those panels. Yes?
So Alaska uses the...
For the purpose of the recording, they told us that
for the benefit of others to hear your questions, it needs to go in here, so it is recorded.
Thank you, Anwar. I keep forgetting that.
So Alaska uses the pile to pier cap connection as a controlling connection in terms of basically a fusible link for our seismic. And can you speak to that issue with the retroactive, the post construction cap assembly?
I cannot. My understanding that the state of New York, the state of California is doing some research on the seismic performance of ultra-high performance connections like that. And in my mind, that's an excellent question. As you start to shorten up that connection and potentially stiffen it up, what is the performance of it in a seismic event? I can't speak to it, but I believe there's research going on right now.
What's the cure time you expect with this product? Are we talking days, weeks? When you're putting hours, where are we at to be able to put traffic on for putting these panels together?
We'll let Barry come in too, but I'll give you my answer. Days, typically. With your mix, you can modify your mix for a faster or longer cure time. It's very temperature dependent, and so once you get it placed with elevated temperatures, you can get your strengths more quickly. But usually a couple days to get to the 14 KSI. Let me say explain what I mean there. It's recommended that even though you're 28-day strength, you're oftentimes looking for something over 21 KSI. The FHWA guidelines recommend that you get at least 14 KSI before you start applying loads. And the 14 KSI you can typically get in 48 hours or just over 24 hours on the Pulaski Skyway in New Jersey. When they were, during the summer, when it was getting kind of warmer, they were almost getting that 14 KSI in a day. My point there, though, is it can be very temperature dependent. Barry?
Yeah, we got the 14 KSI in under a day, and we did it in, I think we were pouring, it was late October. I mean, we had nice weather, but we were surprised at how fast. We almost had it in 12 hours.
So your development length and your simplified rebar connections are all based on that higher strength, right? And the presence of the fibers in there?
Correct.
So is the 14 KSI the magic number for your development length calculations to all work?
Yes. And so the FHWA guidelines for both traffic, for the application of load, and for the use of those rebar lengths is based on that 14 KSI. All right. Let's move into the everyday counts deployment picture for ultra-high performance concrete. Given the benefits of ultra-high performance concrete, FHWA has included it in the Everyday Counts initiative. Since when? 2011, there's been 3 two-year rounds of Everyday Counts, and the bridge-specific or structural engineering-specific innovation in round 1 was prefabricated bridge elements and systems. And prefabricated bridge elements were also in round 2 as a part of ABC, or accelerated bridge construction. And then rounds 3 and 4, the structural specific innovation or bridge specific innovation has been ultra-high performance concrete, using ultra-high performance concrete to connect prefabricated bridge elements together. The purpose of including ultra-high performance concrete in the Everyday Counts initiative is to improve the connections of prefabricated bridge elements by helping to make the connections between precast bridge elements stronger, simpler, and more durable. The goal is for by the end of Everyday Counts across the country, bridge designers, engineers, and material personnel have an understanding of what ultra-high performance concrete is, what the benefits are to using it, and connections and prefabricated bridge elements, and where they can get additional information on using ultra-high performance concrete. Looking at goals, a measurable goal for everyday counts is by December 2018 for there to be 25 agencies that are at the demonstration level or higher. And I'll explain what that means in a minute. But basically what it means is 25 agencies that have at least used ultra-high performance concrete. And also by December 2018, for there to be 100 transportation projects in the country that have used ultra-high performance concrete for connections. The most recent status report last June, there was already 23 agencies that have used ultra-high performance concrete. They're at the demonstration level or higher. And at this point, there's, or at least at last June, there were 63 projects, transportation projects in the country that had used it for connections. So as a part of everyday counts, agencies identify their level of experience with ultra-high performance concrete, and they establish goals for where they would like to be at the end of everyday counts. And as a part of everyday counts 3, in January 2015, 12 states had prior experience with using ultra-high performance concrete. 12 states were at the demonstration level or higher, and 32 states had the goal of eventually being at the demonstration level or higher by the end of everyday counts. Let's take a quick look at these different measurements of experience with ultra-high performance concrete. Not implementing means the agency has no plans to use ultra-high performance concrete at this time. An agency that's at the development stage is learning, gathering information on ultra-high performance concrete. At the demonstration stage, the agency is testing ultra-high performance concrete and has one or more demonstration projects in progress or completed. At the assessment stage, an agency is assessing their prior use of ultra-high performance concrete, deciding where to go in the future, potentially developing guidelines and standards for its use in the state. And at the institutionalized level, the state has adopted ultra-high performance concrete and has probably has standards or some guidelines for its use. Can anybody guess in January 2015 what the one state was that reported they were institutionalized? New York, yes. On this map, we see the 12 agencies that in January 2015 reported to be at the demonstration level or higher. And then last June, 10 additional agencies reported to be at the demonstration level or higher. So what that means, in an 18-month period, 10 additional agencies used ultra-high performance concrete for the first time. And at this point, there's still 10 more agencies that have the goal of eventually using ultra-high performance concrete. This map shows all the projects in that we know of, all the projects in the United States and Canada that have used ultra-high performance concrete in any way, not just for connections, but using it for members, to make prefabricated bridge elements, or for overlays. So as of last August, there was 80 projects in the United States and Canada that had used ultra-high performance concrete. And you see some clusters here in Ontario, New York, Pennsylvania, Iowa. In the United States, we were talking about New York. Yes, they have the most projects. They started in 2009, and I believe they have around 45 projects where they've used ultra-high performance concrete. Pennsylvania started in 2013, I believe, and they have 10 projects where they've used ultra-high performance concrete. Iowa probably has the most diverse use of ultra-high performance concrete. They have 4 projects where they've used it for connections only, and they have 4 other projects where they not only used it for the connections on the bridge, but they also used it to make the prefabricated bridge elements. And then they have 1 project where they used ultra-high performance concrete for an overlay. This map, you can access this map on FHWA's website, and I'll give you the link here at the end of the presentation. but it's an interactive map. And by clicking on the dots, you can get additional information on each of these bridges. For example, who's the owner, what's the location of the bridge, how was ultra-high performance concrete used, and when was the construction completed. And on this web page, below the interactive map, all the bridges are shown in tabular format by year of construction. Some of the challenges to using ultra-high performance concrete, at least for some agencies, is familiarity, specifications, cost, and the number of active suppliers. Many bridge owners and construction personnel are not familiar with ultra-high performance concrete. Currently, the AASHTO specifications do not address the design, the construction, and the material testing of ultra-high performance concrete. And ultra-high performance concrete by the cubic yard costs significantly more than conventional concrete. And currently, the number of suppliers is limited. The everyday approach to addressing familiarity is to facilitate the sharing of information between the states. By gathering all the information that's available nationally, that can be used to increase local familiarity. The FHWA approach to specifications is to provide guidelines for the design and construction of ultra-high performance concrete. Provide guidelines for the use of it. And the everyday counts approach to cost is to focus on connections where the quantities are small and therefore the costs are small, but the benefits are quite large. And the best way to influence the number of active suppliers is to promote the use of ultra-high performance concrete and increase the number of agencies that are using it. In the past, there was an issue, a Buy America issue, as far as having a domestic source of the steel fibers on federal aid, and this applied to federal aid jobs due to the Buy America requirements. But since 2013, there's been a domestic supplier of the appropriate steel fibers, and so this is no longer an issue. So in the absence of AASHTO specifications, FHWA is providing quite a bit of information on the use of ultra-high performance concrete. And you go to the Office of Research's website, you'll see numerous reports and articles. But the most important of these to helping state agencies is the Tech Note of October 2014 that provides guidelines for the design and construction and material testing of ultra-high performance concrete connections. And you can access this online. At the end of the presentation, I will give you these links again. And we have a few copies of this if one of you would like to get a hard copy today, if some of you would like to get a hard copy today.
Tech notes. So do the tech notes trump the LRFD requirement in 23 CFR for use on NHS routes? So specifically the 23 CFR requirement that you use LRFD, we're wrestling a little bit with our division office regarding the administrator's ability to accept standards.
I don't know if there...
So do you have to go through an individual waiver, or is it an automatic trump card over the LRFD requirements?
My understanding is it's not a matter of the tech note trumping the AASHTO LRFD specifications. It's more of a matter that they are compatible. You will need to check me to make sure I'm right, but when you go into the AASHTO specifications, there are provisions where these specifications can be used, or the owner may elect to use other guidelines, procedures that are appropriate for the design, that they deem appropriate for the design. In this case, ultra-high performance is not covered by the AASHTO specifications. And so consequently, the agency will need to investigate what is appropriate to use. And in saying it again, I believe that is compatible with the AASHTO specifications. Okay. In addition to guidelines for the design and construction, as a part of Everyday Counts, FHWA is providing technical assistance, workshops, webinars, peer exchanges, and is available to make presentations. For technical assistance, the ultra-high performance concrete team members are available to do high-level reviews of details and specifications, and to answer specific questions for owner agencies. Workshops are ultra-high performance concrete workshops are currently being offered. As of last fall, 10 agencies have hosted ultra-high performance concrete workshops. I believe last month, Delaware hosted one. The most recent ones, New Jersey, that may be coming up this week or next week, and there was one in Hawaii just within the last week or so. Webinars. There were 2 webinars last September, and there's a series of webinars being planned next year that will be open to all agencies, open to the public. And for peer exchanges, FHWA is committed to facilitate the exchange of information between states that haven't used ultra-high performance concrete and those that have used it successfully in the past. Additional activities for everyday counts implementation of ultra-high performance concrete is that FHWA will develop an online resource library that provides access to existing and new information on ultra-high performance concrete. FHWA will identify and make available example construction specifications that have been successfully used on projects. In the resource library, FHWA will post case studies of notable projects. There are plans to develop videos, short videos, that show ultra-high performance concrete materials and mixing them, placing them, and testing them. And as you can see from the map we looked at already, FHWA has started the process of having a list of all the ultra-high performance concrete projects that have been completed in the country. And at the end of everyday counts, the plan is to update the guidelines for the designing and construction of ultra-high performance concrete connections. The target audience for the everyday counts activities is materials, design, construction personnel that work for and with owner agencies, and that includes consultants and contractors. To get the maximum benefit out of the webinars and workshops, it's good for them to be attended by state employees, local agencies, federal employees, as well as consultants and contractors. I said earlier that online you can get a copy of the FHWA guidelines and you could access the interactive map. Here's the long web addresses for all of those if you want to write them down. However, I've also provided you with some search terms, and just by using these search terms, you'll find that you can readily get to these sites. And the last one here is the ultra-high performance web page on the Everyday Counts website. FHWA is available to answer any questions you have. Here's the contact information for Anwar and myself. You can also get this information by grabbing us before we go today. Our key technical expert on ultra-high performance has been Graybill out of the Turner Fairbank Library. And he, of course, is the author of this publication. Yes, sir?
On FHWA website, go to EDC. You will find all the contact leads on all of the technologies and other links to useful websites as well.
And so with that, while Barry's getting set up, we'll move into, Barry's going to come talk to you about Delaware DOT's experience with ultra-high performance concrete. Let's take some questions. And go ahead. And I just wanted to know. Yeah.
Excuse me. So on the placement of it, so I'm deal with the construction side of it rather than the design side of it, and so. You know,
Yes.
Occasionally the contractors don't do it quite the way they're supposed to, and I didn't see anything that kind of talked about, you know, if you made cylinders, gosh, you need breaking a cylinder that's a 24 KSI cylinder or something might be rather difficult. So, you know, what kind of acceptance and inspection do you do out in the field there? And I actually pulled up your tech note here and was kind of looking at it a little bit, and I wasn't quite sure. It talked about verifying mixing times and that. So are these mobile mixers at the job site, or are these, you know, at a permanent plant?
typically, mobile mixers at the project site are being used. And so the material comes out as a premix, a dry premix, and it's mixed at the site. And given the time for placement, that works out especially well. So that answers, you had a few things in there, but as far as the mixing, it can be mixed at a ready mix plant, but it has proved to be most practical so far to mix it right there at the site.
So the other part of it was like the type of testing you would, sampling and testing you would do. You know, like regular concrete, you might do a slump test, an air test. On self-consolidating concrete, you'll do some spread tests and things like that. You know, I wasn't sure what the inspector would be asked to do. I mean, is there something a little different that they're doing with this? I mean, is it just a visual type of thing? I mean, how do we make sure that what they are actually producing is what we expected to get?
Mm-hmm. And so for material and construction verification, as an agency, you will want to determine what test results you want as an acceptance criteria and what you want to conduct at the site. But what we've been seeing on most projects, we'll pick on New York, what they have in their project, is they have a series of certification requirements prior to construction, pull-out tests, compression tests. But then on the project site, what we're seeing is they do compression tests, they do the flow tests, they verify the mix proportions. So it's right there on the job site, so the inspectors can check that everything that's going in that mixer is the way it should. Temperature of the mix, and then they also do a leak test at the end of construction. And I'm pointing my fingers, but I have no idea what number, if that was 5 or 6. But those, and I could go through those again. But those are the ones they're doing on site.
Just one thing to add. We're doing a lot of these workshops. I think you mentioned, how many did we do? 20-some workshops already?
We're 10 since last fall.
Yeah, we have a goal of some 20 workshops to do. But that's where really we get into the nuts and bolts about mixing and testing and the equipment you need and all of that. It's very difficult to do this in 45-minute presentation. So we have a whole day set up for these things. Also, if you need specific help on a particular project, get with us and we'll get you the SME to help you. And Barry could add to that. I think one of the things, I think your state, you use the stick to purchase a testing equipment with that?
Yeah, so a couple of things regarding that. First of all, unlike a normal concrete pour, before we poured this, we required a contractor to do a full-scale mock-up. So prior to going out and doing it, they have a test batch that they mix up. We do rely on the supplier, too, to be there and to help provide the expertise. But then we actually did the pour, so that they knew what the material felt like, they know how to do the forms. And we had to buy, we used stick money to buy equipment for M&R section because they couldn't break the cylinders. And they sent them out, and on the first project, I think we spent $10,000 for a company to break the cylinders for us. So we had to buy specialized equipment to break our own cylinders because we realized it was something we were going to be using in the future. But that's something you don't really think about, but your equipment you have probably will not be strong. All right.
The question I have is regarding workability, the finish of the product with the fibers in it and stuff. When we've used more of the traditional fibers, not the steel, we seem to have issues where we're leaving kind of a pock surface that wants to hold moisture on the surface. The crews have really had a tough time getting those fibers to finish down and give you a good finish look. So we end up with, like I say, a coarse surface that moisture wants to sit on.
Yeah.
And I saw the puck here. I was wondering if that's been, do we have to buff it when you're done? Or
Well, we grind it when we're done anyway. The way that these precast elements work, and I'll show you, we leave it a little high and we grind it. From what I've seen, there's no finish that they do on the surface. It's a self-leveling type of material. It's very impermeable.
Okay.
Very impermeable.
That was the next question.
Yeah, and you'll see that in some of my pictures. You have to top form it unless you're on a totally level surface because it's self-leveling. So if you don't top form it, you're not going to get the top elevations that you need.
And the grinding is the most relevant response to your question as far as connections, because you do tend to get air bubbles that come to the top, and it's good to grind that off. However, where it's used in a form, a mold, one of the best examples is Iowa's first project where they used it for a BT girder. It's a modified BT girder. And just last summer I got to look at that. And the side of that girder is just as smooth as could be. And one of the things you see with the self-consolidating concretes is you tend to get a really good surface against the forms. And then as far as the fibers, making it a hairy concrete, you really don't notice the fibers at all.
And they're stainless fibers?
They are not, and so they corrode and fall off. But your ultra-high performance concrete, at least the way I think of it, it's really a good insulation for those fibers, and so you do not get any corrosion below the surface. And so you just lose them off the surface, and your corrosion of those fibers stops. And I cannot remember, but I think that bridge in Iowa was done in 2007 or 2009, so it's been out there over 6 or 7 years, and it just has the nicest surface on those bulb tees. Another question before Barry gets started?
Okay.
All right, Barry.
Well, feel free to interrupt me anytime you want. If I'm too loud, let me know. I tend to talk loud, and I don't know how this microphone's going. My theory on this is I think these are made of gold. I'll go into some of that later.
So the corrosion doesn't follow those into the surface of the concrete. I mean, in typical rebar, you have the surface starts to corrode, and pretty soon.
I don't think that's been the experience of states. We've got limited experience with it so far, but I don't believe that that's been an issue. And this stuff's been around for a long time. I get into my presentation. My name is Barry Benton. I am the state bridge engineer for the Delaware Department of Transportation. I've been to several Everyday Count summits. It's my first time speaking at one. Just so you know, I'm not paid by FHWA to speak on behalf of UHPC. But it is really my honor to be here because it's something that we're excited about as a state. And we really started using it just as a result of going to this summit in 2014. You know, before then, we really didn't know what UHPC was all about. So we've done, you know, it's been in the last 2 years that all of our progress has been made. So I have a Secretary of Transportation. That's in Delaware, it's our cabinet position secretary, her name is Jennifer Cohan. She has got a background in service through DMV. She is very high on using innovation to better serve our customers. So that's one of the things that's driving us to try to look at how we can do our business better. As I said, we began considering it after the 2014 Everyday Count Summit. In 2015, we had an accelerated bridge construction workshop because one of our biggest obstacles, and one of yours will probably be too, is getting your contractors familiar with this type of practice, with the material, and having them be willing to go ahead and use it. And you know, as with all state bridge engineers, I'm a little bit conservative by nature, right? We want quality bridges. We don't want to leave things that are going to be a problem for future bridge engineers. And I've been hesitant to use prefabricated deck panels prior to UHPC for one of those reasons. Is just the connections I was always concerned about. So this is our slide showing our accelerated bridge program. We even have a nice cool logo so you know it's got to be real. And as part of our program, we said, what kind of projects are we going to use it on? Obviously, roads with high ADT. And in Delaware, we're a real tiny state, right? But we're very diverse in that the northern part of our state is really urban, a lot of high traffic. I-95 corridor goes through it for about 11 miles. We do charge cars like a $6 toll to go through that 11-mile stretch, pays for a lot of our projects. But you know, also long detours. In the southern part of our state, we're rural, and we have what we consider long detours. Now, some of you guys have detours probably longer than my state, But, you know, those are things where we consider where we want to build faster, right? And we also wanted to consider it on projects where it could, you know, impact a critical path. So the types of bridges, you know, just like Mark was going over, types of bridges we consider are bridge deck replacements, adjacent box beam bridges, next beams, which are very similar to the bulb T's. They're just, I don't know if you've ever used them. They're kind of like the garage T-beams. Superstructure replacements using modular units, and even a deck overlay, which we currently have in our program. We're waiting to hear back from FHWA on a grant for that, though. So, our first UHPC connection experience was actually not a UHPC connection experience. It happened, it was a little project we had in a town in lower Delaware. It was in the middle of town, there were schools on both sides, and they wanted us to build it over the summer, so we used an entirely precast structure. And we used next beams, and the next beam details called for UHPC. Now, I had a very good senior designer. He is a Jamaican fella who worked for me, a good friend of mine. And I still remember he came into my office and he says, look, man, I don't know nothing about this UHPC business. And my Jamaican accent's bad. But he said, I want to use high strength grout. And he's like, I don't even think we can get this stuff through Buy America. You know, it was in 2013. And he says, I think we can accomplish the same thing with a high strength grout. So that's what we did. So this is what it looks like. You can see the next beam is just a double beam. They're 8 feet wide. They have the connections very similar to what you would see on a bulb tee. And we were going to put a membrane and hot mix over top of it. And the project went off, and they're highlighted down there. We're using high strength grout. The project it went very well. Just a little bridge. We got it replaced over the summertime within like a month and a half, and everything was well, everybody's happy. But at the inventory inspection, that's what these pictures were from, we started noticing that the joints looked like they were a little bit wet. It looked like they might have been leaking. So this is what we saw 2 years later in our 2015 bridge inspection. And we already had heavy efflorescence at the shear joint. You can see water flow coming openly through the joint. So we had a couple issues. We had our membrane was failing, but more importantly, this is the performance we were getting out of our high strength grout. So some of the lessons we learned, we ended up having to go back and mill off all the hot mix, put a new membrane down and try to seal the top of it, and it seems to have stopped some of the water through it. But what we learned is that high strength grout is not equivalent to UHPC. That the money saved by not using UHPC, because that was one of our things too, it's too expensive, why are we going to use this, was lost in maintenance. And we liked the use of the next beams, we were able to build fast, but we needed to come up with a better detail. So we figured we better find out what this UHPC business was all about. And that's what took us to the 2014 everyday counts and why I ended up in the room with the UHPC. So, I always take a designer with me when I go to everyday counts. I'll take my bridge design engineer, but I like to take designers who are actually doing the work, because they're the guys I want to get excited about the things that we're going to be implementing. And we sat through, and one of the designer I had with me, he had a project. It was a simple project. It was adjacent box beams, nothing critical. It was in the rural road, not where we would normally consider UHPC. And he said, you know what, I want to use this on my project. We always get the cracking between the adjacent box beams. It was a low ADT road, it was a low risk for us as a state agency. And I said, you know what, this might be a good opportunity. So he went back, and he was at final plans. He went back and he revised his details, called up some precasters, told them what he was doing, and we ended up putting this thing out. Within a couple months of everyday counts, we ended up advertising this project after we had come back. So Mark was referencing the problems some states have with adjacent box beams. This is a plan view of it. And in Delaware, we had some funky details. Everybody tries to address the cracking issue. We had the post-tensioning across with tie rod bars, and then these little squares are actually shear connectors that they go into each beam. They're spaced at like 4 feet, and we weld these little squares on there to try to do something to keep from having the movement between beams and the cracking. And it never works. We always get cracking on it. So you can tell that pretty intense detailing for a bridge that's still going to crack. So this is what my designer came up with. Is just very simple. You had studs coming out of each side, and we're just going to fill it with UHPC. We got rid of the post-tensioning, we got rid of the shear studs, and it was very, very, very simple for him to change in detail. Now, it was more difficult for the fabricator to make. The fabricator, he had his shear key, forms already done, so he had to come back. He did not have a way to extend the bar out of the form. So what he ended up doing was putting in threaded inserts on the inside. And you can see that's what that picture on the left is. And this is what it looked like after they had set it that day. So this is our first use. We're all excited. We had a pre-pour meeting to go down and discuss how we're going to lay this in. We did not have the most astute contractor. He was thinking, he really did not do a lot of investigation, at least the foreman didn't, into what it was. And he thought he was just pouring grout. So we had to have a second meeting with the supplier on, and he had to do a test pour. But even so, we had a foreman who was very determined to do it his own way. So I put this picture, this was them on the left-hand side. So you got pre-stressed concrete beams with a little bit of camber. They're trying to shovel this in with a wheelbarrow, taking them all day. It's wanting to self-level out the end. He was refusing to top form it. The guy from Lafarge was going out of his mind. He was like, he could not get through to the contractor to do it his way. So the representative from Lafarge started taking boards, laying them down, and top forming. He borrowed one laborer. There were 9 joints. The foreman refused to give up. He did the one on one side and then did the one on the other side. The guy from Lafarge with his one laborer did the other 7. But even as he's laying these things out, the foreman would not give up. But it ended up being a really good product. So what they did, he top formed, he used buckets. He just dumped it into the buckets, used the pressure the stuff flowed from one end to the other. We got a really good product on it. And the guy from Lafarge, he was hilarious. He was cursing like crazy at that guy. But this was our final product. And it ended up being, a deck that was just absolutely beautiful. Not a single crack in it. So, some of the lessons we learned. Listen to the supplier, right? And we cannot stress that to our contractors enough. UHPC forms must be tight. They got to be watertight. And we had them water tested. The contractor was furious that we made them water tested because they had to filter water and suck all the water back out. The cast-in-place deck was overkill. I don't think we needed it here. It was our detail. Our next one will not have a cast-in-place deck. We'll either have a membrane and hot mix or just a thin overlay. Actually, we're looking at doing a UHPC overlay. UHPC was expensive, and I'll go into that later. But the new details for the precast box beams, they were a little more expensive, but not as bad as we thought they would be. But the end result was what we want, which is going to be a durable bridge. So we took this and we built on it. We had another project in design. Another designer went out and saw this. He's like, I want to use it. I have some next beams. It was a marsh setting. Once again, this was not for speed, but we did this because we wanted a durable product. It'll get inundated by the tide occasionally during storms, and we didn't want box beams because we don't want water getting into the beams. So we ended up using the next beam, and it was a low ADT road. Once again, it was a low-risk project for me. This is what the details look like. These are the next beams, very similar to the one that we did not use the UHPC on. And you can see very similar details though. Just lay them out. You got a total of 4 beams that get put in there, and then you just fill it with UHPC. This one, I had a contractor who was very good. Listened to the supplier all along, had absolutely no issues with it. But here's the beams going in. See, they put them in pretty quickly. He formed it up on the bottom. He had it dried up and just used forms and jammed them up in there. He did do the top forming. And I like that picture. One of the issues they had was the mixer was small, and they couldn't mix as fast as he could place it. So that was kind of the driving point for here. But you can see the shear keys, very simple. Just a stud on each side and 2 pieces of bar going down. Very, very simple to put the rebar in, very easy to construct. And for his top forms, he used just concrete blocks to hold the forms in place. but he also used them to help balance out some of the camber between the beams, because when you have pre-stressed beams, especially some with barrier, some with not, you get some variations in camber, and he was able to do some leveling of the beams with the weights to get it even, because we did not have an overlay on this one. But we had it was a thin epoxy overlay. But this was the final surface after grinding. See, I mean, it came out really good. They UHPC'd it a little bit high, ground down the surface, and then they put what we call is a thin epoxy overlay is what we call it. It's basically the epoxy and then the grit. The final result was really good. You can see the marsh type setting there, but we have a really durable bridge there. So really good experience for us. So some of the lessons we learned from this one, once again, listen to the supplier, right? Forms must be tight, and contractor here did a terrific job of it. UHPC is expensive. Looks a little bit similar to the first ones. The mixer was too small for the job on this one. But the beams had camber differences, but we learned how to deal with that with the weights. But the end result, once again, really good product. So we're starting to get really excited for it, and now we're ready to go from the low-risk jobs to a high-risk job. So my high-risk job was, and this was what kind of our goal was all along. This is on I-95 northbound. It's over 100,000 cars a day, okay? Big time location for us. It's right near the shopping malls. There's never a good time to do it. And we had precast slabs with a PPC overlay on top of it. And we chose to use an overlay it's like a 3/4 inch overlay in case we had any differences in the slabs. But very high volume, very high profile job with phase construction half at a time. Now, New York DOT, they do bridge deck replacements in 3 days, 4 days. We haven't had that kind of success. Our contractors, I mean, and this was a difficult job, I'll show you, but you know, we completed this in 32 days. It was projected to be about a 4.5-month job. So we cut a lot of time out of it. And it's something that we're really happy with and are going to use in the future. So you see it's 4 spans. You got the precast slabs that went in. It looks very similar to some of the details Mark was showing. One of the things, we did not eliminate the joints. It was on a skew. We left all the joints in place, which actually provided us with a nice divider too, so we didn't have too big of UHPC pours at a time. In case anything were to go wrong, we wouldn't have had the whole bridge. So some of the details we used, our slabs went across some beams. Where they didn't, we had them rest over the beam. That's the detail on your left. We filled those with UHPC, and you could see that joint from the top. But where we went over top of a beam, we had what we call a pocket detail. So we could have the shear studs remain on the beam, and the slab just went up and over. And then we had holes in the top spaced at about every 4 feet, and you could see it as it filled up because it would actually come out of the next hole. And the UHPC then makes it a composite deck. So here's some of the pictures of it going on. Once again, we did have a really good contractor on here. He helped work through some problems. We had tolerance issues on our precast slabs, but because you've got a 4 to 8 inch joint there, you got enough room to take up some of the tolerance differences. And because we were putting in an overlay, if they weren't exactly level, it wasn't a big deal because we were going to grind it down and put an overlay on it anyway. But this was preparing for the pour. Here's the mixers. We had problems before we started. We had 2 big mixers. We wanted a backup plan. One of our mixers broke before we even started. They ended up getting it back online. But the first pour did take longer. It took like 12 hours because we had mixer issues. Still not a bad deal. And this was the final surface after grinding. And then on the right, you can see we're putting down the PPC overlay. It's like a light brown, very thin overlay on top of it to help take up for any of the differences. And I have on here, let me see if this will run. I have on here a video. So this is just a snippet of, it's about a minute long. And in the video, you'll see they bring in the little buggy that's carrying the UHPC. He'll come in, he's going to dump it into the trough. The troughs are set up over the joints. They actually filled up a lot of the joints without the top form. And then when they get near the top, they would put the top forms on. The top forms are set about a 1/2 inch high. And then we just come back and we'll grind the difference off. But they were able to watch the UHPC flow through. We had guys underneath checking for leaks, but because it's water tested too, we didn't really have a big issue with that. And you'll see as we turn to the right, these are, those right there, that's one of the intermediate beams. Okay, so those are the pockets. You can see they're spaced, looks like they might even be every 2 feet. So as they're placing the UHPC over top of one of those with buckets, they can see it forcing out of the next one, then they would cap it. And that way you make sure you're completely filled up. So some of the lessons we learned, once again, listen to the supplier, right? Forms must be tight. UHPC is expensive. Backup mixer is a must. Tolerance and lead time on precast was an issue. Our precaster really, I was disappointed in what we got from the precaster, but we were able to adjust in the field. We had, at our joints, all right, where we had the expansion joints, we had some reinforcement issues. That was more from the reinforcement coming off the expansion dam. But the UHPC had no problem, because it's like pancake batter, had no problem going around it. And we also learned that we want to use leveling screws on our next one, because we set grades with the angles, which caused us to have some very heavy angles, and also it was a little bit tough to control. So if we don't want to do an overlay, we're going to use leveling screws on the next one. So from here, where do we go? Our next project, this is actually really cool. It's bridge 1-680 for us. It's another high volume roadway. It's a high volume roadway over a high volume roadway. There's no room to do this half at a time. We have to go in and do a full closure. The bridge is over 700 feet long. We're going to do a complete closure, working 24/7, try to get it done within a summer. Once again, we've got a lot of schools in the area. Precast deck panels with UHPC connections, and we're going to do no overlay. So it's going to be, we're going to just grind it and go. Similar details to Bridge 717. One of the cool things, we went to a recent public workshop to tell them, look, we're going to close your road with 40,000 cars a day on it, and we're going to try to get it done fast. Overwhelming support from them. They wanted us to do exactly what we did on I-95. We got a lot of good press. Another good thing for you state DOTs, our Secretary of Transportation recently went to our budget hearing, and one of the things she did was present what we're doing. And we did a time lapse of the project we did on 95, and she got a lot of support, and we ended up getting all the money that we asked for. So you can buy a lot of credibility also by the performing. We have another project coming up. Now this one is a smaller project. It's got it's a low volume roadway, but it's a complete closure with detour, and it's a pretty long detour. So we're doing all precast bridge. It's going to be adjacent box beam, similar to the one I showed you earlier, but we're not going to do a precast concrete deck on it. Instead, we're going to do a thin UHPC overlay. And we applied to FHWA for an AID grant for it. It's going to be a little more expensive. We're excited about the possibility of using this. And once again, having a durable bridge that we don't have to go back to for 75 or 100 years. After that, we've got two bridges. Once again, these are over I-95, and this is on the same roadway, 141, another high volume roadway. This is going to be phased construction. We're using prefabricated modular superstructure units with UHPC connections. So I'm ticking all of your project types right off, Mark, you were talking about. We're going to bring these in. We'll set them side by side. It takes it off of the critical path, takes it from a 2-year project to a 1-year project by using UHPC. And we're also using precast piers, and it's going to be an accelerated project. And then we have another one. This is another deck. It's going to be a long detour, one phase. We're going to do deck replacement. And every time we do this, we're looking to learn, improve our details, but I don't want to change my details a lot, right? My contractors are starting to get used to using UHPC. I want them to get comfortable with the details we're using. We're getting feedback from them on our previous projects so we can learn to make them a little bit better for them. But we want to just keep on, we want to keep tightening the time a little bit. We want to keep improving our details. And so we'll be using very similar details to what we use at 717. So my last part I want to talk about is the cost. The cost of this, we were told anywhere from like $3,000 to $5,000 a cubic yard. We're not really seeing that. We're seeing more like $7,000 to $8,000. We've only done a few projects. My first one, it was $425 a cubic foot. The second one, I had $200 a cubic foot, but if you looked at the precast price, it was a lot higher. So I think he just did some shifting of some of his costs. And then the last one we did, we had $283. So we're right around an average of around $300 a cubic foot between the projects. The beam cost I talked about earlier, we had different details for the beams. It wasn't a big deal though. We're looking at $2,600 for the adjacent box beams per cubic yard versus $2,100. Wasn't really a big difference in the beam cost. My deck cost was a lot. So my first precast deck, comparing previous deck jobs we've done, I get around $54 per square foot. I know that number is all over the place, depending on where you are in the country. But my cost was around $54 a square foot. With precast panels and UHPC, I'm $140 a square foot. Okay, so we're talking, 260%. So on this job, it would have cost me around $1 million to do a deck. Instead, it cost me $2.6 million. You say, wow, that's big. We're a small state. My budget's $30 to $50 million a year for bridges. I take that seriously. But when you look at the user costs and MOT costs, so I cut off 94 days off of this project, okay? My MOT costs, if I go by my daily costs, drums, signs, lights, all that, were $8,000 a day. So of my $1.6 million, I get $800,000 back in MOT costs alone. So that $1 million job with the added MOT would have been 1.8 versus 2.6, looking a lot better. If I look at my user costs for this job, just doing it in phase construction, dropping the lanes, my user cost was $18,000 a day. It makes it easy for me to make the decision to use UHPC. Not to mention that we had to fit it in a window pretty much from the from the middle of October to have it open by Thanksgiving for shopping because of all the shopping malls in the area. So it was a really big win for us and actually a very easy decision to make regarding costs. So some of the stuff that we've done, Mark was talking about the deployment from the federal highway standpoint, but from Delaware standpoint, we had to get our community, our contractors, our designers, everybody ready. So in 2015, we co-sponsored an ABC workshop with FHWA. This was at our initiative, but we worked with FHWA and we invited our neighboring states. We're lucky, we have New York. New York's a leader in the country in this, and that's why Wahid Albert, he's their chief engineer now, he had to take vacation time because they would not let him come to speak even if we paid for it. But he came and talked to us and he brought a contractor with him. And what was important about our workshop, we had our contractors and our consultant designers there and we went through a lot. And we presented it from a design standpoint and from a construction standpoint. Pennsylvania also, Lou Ruzzi came and he brought a contractor also. And we wanted to get our contractors on board and understand what we're trying to accomplish. We use stick money to purchase machines for Delta M&R for breaking UHPC samples. And as I detailed, we tried UHPC on some test projects, some low-risk projects, before we used them on high-profile jobs. The future, we've pretty much skipped the assessment phase. We went from a pilot phase to now we're really in full implementation. If it makes sense to use it, if I can justify it, I'm going to use it because I've not had anybody complain to me about getting a bridge done too fast or getting a bridge done that doesn't need me to go back and maintenance. So we're going to continue to use ABC and UHPC on projects where it makes sense. We're going to continue to improve our details, but still keeping them the same. And we're always going to seek more training for our designers, contractors, and inspectors. And that's one of the things. So we've had a couple of workshops, and we just recently hosted the UHPC Connections workshop. And we include our contracting community in all of these workshops because that's what I see as my biggest obstacle. It's easy for a designer. The details for designers get easier and they just specify it. Contractors, the guys got to work with this stuff. and it's very sticky stuff. It sets up pretty fast, and the forming is totally different. So we've included them in all of our training, and we've had good attendance from them. So that is all that I had on this, and I'll be willing to take any questions now that you guys have.
Thanks, Barry.
So that leaves us with, very good, thank you. So we have 5 minutes for any questions you have, and I might let Barry kind of start off with answering the questions, and I'll bring up a video I think you might like to see, a very short video. So please, any questions you have?
Well, I must have
Not
covered
a
it
question,
great.
maybe a comment for Barry, and you've already touched on it. So for those states that are on the, on the fence, they're not all in, what advice would you give to them? Where to start? What's a good starting point for them?
I mean, for me, it was easy, right? Well, first of all, get some of your designers involved. Get them involved in some of the training, the webinars and stuff, because once they see it, they get excited. But then, pick some low-risk projects, and when we picked those low-risk projects, of course, the first one with the box beams, first thing contractor wanted to do when he found out what UHPC was substitute it, and we said no. This is something that we want to see how it's going to work. So pick some low-risk locations, get familiar with it, It helped us to gain confidence with it, for sure, but I would say don't be afraid of it either. It was a new material to us, but it's not a new material. It's been around for a long time. It is tried and true. We've had really great experiences so far.
Any questions? Did you have any issues with developing of specifications for it?
We did not. Well, we contacted New York State, and New York State sent us their specifications. And we kind of vetted them through our specifications folks. But it was something, I would say also you don't need to reinvent the wheel. There's been a lot of work done. New York State DOT was probably the best resource for us, that and FHWA. If you contact Ben Graybill, Ben Bierman, those guys were terrific and very excited to help us out. So, don't be afraid to use FHWA as your resource.
All right, sounds like we don't have any questions. I think you've answered all of my questions I had through your presentation, so I really appreciate you taking the time and coming here and share with us your experience in DelDOT. And by the way, your presentation and your time, I don't think we can consider that in your grant application.
Please, we're still waiting to hear back. I did have a video too of our. This is Marc's video. That's exactly how we saw it flowing. We had concerns from folks about, especially the connections you can't see. The pocket connections on the precast deck panels, about how it would flow through. When you go out and watch it get done, you see them. Yeah. Yeah.
Between the girder and the deck. Go ahead.
Yeah, and then you have pockets on top, and you see the UHPC being forced out of the pocket on the top. You feel very comfortable that that is coming up through. Can I show you my video too? I want to. My video is it's like a minute long, I think, and this was what our Secretary of Transportation used. If it'll come up, here it is. So this is what she used at the budget hearing to show people. So this was, like I said, this was over 30 days, but it was done in phases, just so you can get an idea of how tight the work site was, the traffic was involved, and even the removal of the deck. It was very difficult. It's a high volume roadway underneath, so they're having to be very careful. They have shielding up to do it, but then the deck panels just coming in and just. You can see, once they got the demo done, the deck panels went down in like half a day. I mean, they went down so fast.
And the barriers connected to the panels?
The barriers connected to the panels. They use UHPC on the barriers as well as on the deck. They did you can see the second half is going to go a lot faster. Now they got traffic on the first half. The second half, because the contractor learned. He picked up momentum, and then, the deck was done. And it got really good really good press, which is unusual for Delaware because the newspaper won't put anything in unless we've messed something up.
On that barrier joint, did you bring the ultra-high performance concrete up?
We did. We used UHPC on the barriers too. So, and it came all the way full height.
Any questions? This is not your last opportunity to ask questions. Anwar and myself are always available to you. Get one of our business cards before you go. We're here to help you with any questions you have, you or your agency, with ultra-high performance concrete. Thank you so much for attending today.
I have business cards also if anybody wants one. I'm sorry, I didn't put my contact
We
information.
don't have many of these, but if you'd like to get a hard copy of the tech note, I have these here as well.
Great, so how about a round of applause for Ben for Barry and Mark. Thank you, guys.